So you have a test literally on Friday. So for Monday, Tuesday, and Wednesday, I'm going to teach you, like, here's how you graph a line and shade underneath it. And then we'll graph another line and shade to the right of it. And we'll graph a third line, we'll like shade above it. And then they'll all overlap like this. And that creates something called the feasible region. All right. Now this is going to be centered in like the real world, where maybe in this case you have a choice. You only have so much flour and you're baking things, and you're going to make cookies on the x-axis, and on the y-axis it's going to be cupcakes. And again, you only have so much flour, and so you're constrained. You can't just make unlimited. So you figure out that you can make this combination, which would be like 1, 2, 3, 4, 5, 6 cookies and 1 cake. That'd be like 6, 1. Or you could make this combination up here, which I was being a little loose with my points here, but that'd be 1, 2, 3, 4, 5. This, I think that's supposed to be on the axis, so that's going to be 0, 6. So you could make 0 cookies and 6 cupcakes, or you could have something in the middle, like maybe in here. And that point right there might be like 3 cookies and 3 cupcakes. All right, so moral of the story is, in the real world, you have to make choices. Even giant companies like Apple have to make a choice. How many of the iPhone Maxes should we make versus the regular iPhones? And they have really smart people working really hard to try to figure out what combination we should sell. Because if they make a ton of iPhone Maxes and then they don't buy them, then that was a huge waste of space. We should have made more of the regular iPhones, etc. All right. So here's the fundamentals. That's the big picture, and that's where you're going by Friday. So all we have to do today is learn how to write equations and graph the equations. All right, so let's start with writing equations. Everybody, please put X is going to be cookies, and Y is going to be, not going to make cakes because it'll have a C at the beginning. So let's go with muffins. If X is cookie and Y is muffins, and we can only sell these things in little plastic tubs, and we only have like 8 plastic tubs. Like, that's all we got. So all we can do is make 8. There's an equation for that. Don't overthink this. The constraint is we only got 8 plastic things to stick them in. And the school requires, if you're going to have a bake sale, that they all have to be individually wrapped. You can't just like have them out on a plate. What's the equation? Don't overthink this. Talk to the kid next to you. What's the equation? Hint of it has an equals in it and it has a plus in it. All right, come on, you can do this. This is not that hard. Talk to the kid next to you. Maybe they'll give you an idea. Alex, would you just say that out loud?
X plus Y equals 8.
X plus Y equals 8. That's all it is. You got X cookies plus Y muffins equals 8 total, because that's all we have is 8 little plastic things to put them in. Okay? All right. Now, let's do another equation about our cookies and our muffins. Let's say that we know from past experience, we've sold these things before, that we can get $2 for these are big old monster cookies. We can get $2 for those, and we can get $3 for the muffins. Typical bake sale thing. Can't be like super overpriced. That's about right. Then there's an equation for that. Except I need to tell you what it totals, because if you add together the money you got from the cookies and from the muffins, you earn $25. Again, don't overthink this. It's an equation, so it's got an equal sign. And you pretty much always add something together. And we know it makes $25, so it equals 25. Could it just be X plus Y equals 25? No, because That doesn't even include the information about how much we're charging for the cookies. Yes. There it is. 2x plus 3y equals 25. Who was kind of thinking that? You kind of had that feeling. Good. That's good instincts. All right. Now, do you get, if you graphed this and this, that you could graph those? That's things you could graph. And they would be lines on a graph that would kind of look like this and maybe like this. And if you shade it in certain directions, you might get a little area like this. That's what's going to happen down the road. But for today, we just got to write the equations and then graph simple ones. Yes?
There's only 8 bags and you only sell muffins. You can only get up to $24.
That's exactly what you'd figure out on actually graphing these. And I don't want to do these because they're so complicated. But you see, what happens is you have one constraint that says this, and then you shade underneath it. And the other constraint says that, and you shade above it. And then you realize you have to satisfy all the constraints. So then you end up finding out that you can only do something like in this region right here. And then you're like, well, we for sure have to stay under 8. That might be a line that actually looks here. Your point is that, hey, you can do this at the same time. You're exactly right. That's kind of the point. Once you graph this and you graph that, they'll be separate lines on the same graph. And you'll have to shade then under them or above them and figure out what is possible. And what is possible are any spots that are inside of these shaded in areas. And then those are the only ones that are possible. And they will for sure stay 8 or less. And that would look like this. Here, big picture. Here's what 8 or less looks like. If I had to stay under 8, that would be like this. Okay. So the equation, you've realized an important thing, but it is covered. The system works if you graph both lines. All right, so now I got to just start you off on nice, easy ones. So we're going to take the x and the y-axis. Everybody make one of these. And first, if you just can't graph x equals 2, then we're kind of stuck. Like, we have to graph the easy ones first. So can you just graph x equals 2? Hint, it's an equation. It's a line. And it starts where x is 2, but then it's a line. It's not a point. You take it out and you don't put it. All right, so x equals 2. Well, I know where x is 2, Mr. Server. X is 2 would be right here. But to make the line x is 2, it goes like this. It would be very easy to get that backwards. I totally get it. Because it's right next to the y-axis, and it might feel wrong to you, but that's where x equals 2. Okay. Now, what if instead of x equaled 2, I had said x is greater than 2? Well, then, that line doesn't actually work anymore because things that are on that line are equal to 2, and we don't want it to be equal to 2. We want it to be less or greater than 2. So first off, you'd have to change it to a dotted line. And then, if it's greater, I bet your gut feeling says to go to the right, and your gut feeling would be right. Now, I've done this for a long time. Trust me, you only want to shade a little bit on one side of the line. Kids make a big mistake by grabbing a highlighter and then like highlighting in this whole area, and it'll get so messy after you've had your third equation, you won't be able to tell where the feasible region is. So trust me, just shade a little bit on one side of the line. Kind of like I just did there. Okay? All right. That's x is greater than 2. Notice it has a dotted line instead of a solid line. And it's shaded to the right of the line. Every single point over there, if I pick this one, for instance, its x is bigger than 2. So it works. Everything on the left side of the line, the x wouldn't be big enough. So any point over here just wouldn't work. Like any spot over there. The x is only 1 at that spot, so it could not work. All right, now I'd like you to graph the equation y is greater than 0. Without my help, slap it on the same xy axis. Because that's what's going to happen. You're going to graph like 3 things all on the same equation. They're all on the same graph. And just a quick look. Several kids hadn't graphed it yet because I'm not sure they knew where it was. And one kid had graphed it the wrong way. So I can tell we're going to need a little bit of help on these. Where is one spot where y equals 0? Well, right there's a spot where y equals 0, but the tricky part is both x and y equals 0 there. So you got to figure out, well, if my x line went up and down, my y line is going to go left and right. So that is the x-axis. It's definitely confusing. The x-axis is y equals 0? Yes, it is. The x-axis, if you wanted to graph it, or graph something on it, you'd type y equals 0. But I said y is greater than 0, so I made a dotted line. And now I'm going to shade, drum roll please, greater than, above it. Okay? And now the last kind of equation that you have to graph is something that you haven't graphed much since like 6th grade. Y equals negative 2x plus 8. Now, if you have to graph that, first of all, you have to remember that the y-intercept is where you would start. Do you remember on y equals negative 2x plus 8 what the y-intercept is? Carlos, what's the y-intercept? 8. So you'd go up to 8 on the y-axis and you'd put a dot there. Personally, I'm going to use a white. No, white won't show up really well. I'm going to use a red line. I'm going to go up 1, 2, 3, 4, 5, 6, 7. It's right there. It's technically just off of my graph, so I'm going to extend my line up a little bit there. Okay. And if I was going to graph this, I'd start with the y-intercept, but then I would know that the slope is negative 2 over 1. Do you remember the whole rise over run thing? So it's going to go down 2 over 1. Down 2 over 1. There's somebody that's not with me right now, and I don't want to embarrass them, but I want them to come back. Don't make me go over there. Down 2 over 1. And look, all of my dots line up in a straight line. But one problem. We'll never have one that's just equal. We'll always be shading it. So I'm going to change this to y is less than or equal. It's still equal, still a solid line, but less than. So then, for this green line, don't think left or right. Think above it or below it. And if it's a less than, you want below it. And I hope you can just kind of know, oh, below it would be this way. That's below the line. Now, here's the hardest part. You have to be able to shade where they all overlap and remember its name. Where they all overlap is right in here. And its name that's called the feasible region. Because every point inside that region region is feasible because it would work in all of the equations that I had. I had three equations. I had x is bigger than 2, I had y is bigger than 0, and I had y is less than or equal to negative 2x plus 8. Those are my three equations. Any point in the little blue shaded region called the feasible region will work in all three equations. So if I picked a point that just happened to be right there, it's right on the edge of that and inside that triangle, then that point will work in all three equations. All right. There's the big picture. I have now taught you the basics of writing an equation, and I've taught you the basics of how to graph them. So we're almost done. So let's go back and do one more where you write the equation. I'm going to say x is ping pong machines. I just saw a really cool AI-powered ping pong machine. You can play against this thing, and you can set it to any level you want, and it will kick your butt. Like, it is beating professional ping pong players. And it's basically a robot. It's not like a wall. It's a robot with a ping pong paddle that is going to return whatever you hit over there, it's going to hit it back. Like, it is insanely good. Now, it's not like it can't ever lose a point, but it is so good that it's beating professional ping pong players. Okay, so X is ping pong machines. Y, something else that I've seen that I think is kind of cool, is a little household robot that can actually cook for you. It kind of doesn't have a body. It just has arms that come out and can like flip eggs, and it's got like spatulas and things, and it can like grab an egg off the counter and break it and put it into the pan, and so it's like this little sort of like an octopus looking thing that sits right on your stove, and you can tell it, hey, make me some eggs. And it's still got issues because you got to put the stuff where it can reach it and all that, but anyway, so this is going to be the Octo Cook. So, if I told you that the ping pong machine, those are 10 grand. There's people out there to buy that kind of stuff. Like Michael Jackson, for example, walked through on one shopping trip to a mall. He spent $9 million. One trip. So, like buying a $10,000 ping pong machine would be like nothing. Nothing. And the Octo Cooks, those are 20 grand. But you've limited yourself to only going to spend $100,000 on my shopping spree at the mall. There's an equation for that. The total, the max, not that I have to spend 100 grand, but the most I'm going to let myself spend is 100 grand. Why can't it just be X plus Y has to be less than 100 grand? Well, there's a bunch of things wrong with that. The first thing is, you could actually spend 100 grand. And this says you have to stay less than 100 grand. So I have to make it or equal to. The next thing is, it doesn't factor in the actual cost of the items. So then, I got to put the 10,000 on the X, and I have to put the 20,000 in front of the Y. There we go. All right. You've learned enough for today that you can do today's part. Remember that I get to teach you stuff tomorrow and the next day, and then you're ready to actually start with the beginning to end whole problems, okay? And then we will be doing those by Wednesday. Then Thursday we'll review it, and then Friday is the actual test. All right, where you'll get like a couple of these really big word problems that you got to put all together. All right, so let's start your homework. It looks like this. I'll tell you which ones to skip. I'll do one of each kind with you. Aiden D, can you tell me, is it reasonable to expect that if I cut the assignment down by the last problem on each?
Yeah.
Yeah, I think that's reasonable. All right, so we're cutting off the last problem on each page. And I'll help you start. And I'll give you what time to work in class. And I'm hoping that by tomorrow you guys are all done. Remember that, don't forget, you have to grade your own with the key. If you fix everything that's wrong, you can give yourself full credit, 5 out of 5. If you don't fix everything that's wrong, but you fix some of it, kind of in between, then you get a 4 out of 5. If you just finish the whole thing, just get it all done, do it quality work, you can have 3 out of 5 for just that. So somewhere your scores are probably going to be 3, 4, or 5 out of 5. Don't forget to score it and put it on top. Otherwise, the max I can give you is, if you finished it, best I can give you is a 3 out of 5. All right, here we go. Number 1. Please turn your iPads my way so I can see that you aren't just farting around. You're actually doing this homework with me. And that is almost everybody. All right, I'm going to come and check on the one kid who wasn't there in a second, so get there quickly, kid. Here we go. X is greater than or equal to 1. First thing I do is go, here's X and here's Y. And then I go, where's X equal to 1 even at all? I put a dot there. And then I can go, now I feel like it's going to go up and down or left and right? What do you say? Up and down from there? I agree. Now notice it says greater than or equal to. The equal to means I have to use a solid line because every point on that line will work. Then it's the greater than part is where you shade. And this, you just have to have a feeling for this. Greater means where the X numbers are greater, which is this way. So I'm going to shade it to the right. If it had been a tilted line, you would have to pick shading above it or below the tilted line. If the line's straight up and down, you can, of course, pick left or right. All right, the next one is y equals greater than or equal x plus 1, starting at the 1. That's called the y-intercept. I put a dot there. And now the slope of that is a 1. And that's really a 1 over a 1. Rise over run, remember that? Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I think I've done enough of those. Draw my line through it. Double check that I'm supposed to be using a solid line. Does it say equal to? It does. And then it's just shading. It says greater than. Quan, which way am I? Oh, wait, you're taking the test. My bad. Let's go with Alex Feltman. Which way should I shade, above the blue line or below the blue line? Hint, it says greater than. Above. Yep. And last but not least, Max, can you tell me how to graph y less than or equal to 8? Start with one thing, Max. I'm going to put a dot right here. Is that what you meant? Okay, good. Now, do you think it goes left, right, or up, down? Left, right is correct. Should it be solid or dotted line? Solid. And then should I shade above it or below it? Below it, because this is less than. Now I'm regretting not extending this line a little further, so I just will. That's not that hard. And I bet you can all see that's where you shade at the end. That's called the feasible region. It's shaded in the right directions for all the lines. So every point in there, if I decided to pick on this point, that's the point 5, 7, for example. That point 5, 7 works in all three equations. If I put in x equals 5, it's true. If I put in, again, 5, 7, if I put in 5 here and 7 here, 7 is bigger than 5. And then if I put in a 7 here, 7 is less than 8. So see, every point in there works in all three equations. That's why it's feasible. That's why that's the feasible region. Okay, cool. I helped you with problem 1, which is part of your homework. Then you go to problem 2. And then you go to problem 3. You can skip number 4. But now let's go look at 5. And give you a whole bunch of time to work in class that you should be done. All right, here we are in problem 5. Now, I made the mistake of not noticing this, and I made a big deal about how to tell which should be X and which should be Y. They tell you right here at the end of the problem. X is the hours Kesha works at the Academic Support Center. Okay, so X is clearly hours that she works there. And Y is going to be the hours that she works at the restaurant. Now it says it wants 3 constraints. What you don't maybe know is that a constraint is something like this. X plus Y is less than 20 or something like that. That's a constraint. So when they ask for 3 constraints, they're really saying write 3 equations. Well, from just knowing what X and Y are, I can't even write any equations. But I got to go up into the problem and I'll start figuring out what are 3 equations that I can write. Okay, so Kesha is a math ed major. She wants to earn some money to help with expenses, 2 part-time jobs, tutoring at the support center and working at a restaurant. Okay, so those are the 2 things, X and Y. Although she would like to work more hours at the tutoring center, she likes earning the higher pay at the restaurant. Okay, so she's going to do both. Here we finally have an equation. She can tutor no less than 2. That's one equation. Tutoring's X, says so right here. X no less than 2. The way I think of that is it's not a less than, so it must be greater than. Now, would you interpret this as that she has to work 2 or more? It says no less than 2. Doesn't that kind of mean it has to be at least 2? I think it means it has to be at least 2, so I think that means equals. Greater or equal to 2. All right, cool. First equation done. There's 3 of them. Mr. Breen, give me another equation that's for this next part about no more than 8.
X is less than or equal to 8.
Yes. All right, that was this part. And she can work a total of no more than 20. No more than 20 means not more than, so therefore less than or equal to 20. But what adds up to that? Oh, X plus Y adds up to that. All right, I'm going to warn you on this next problem about the burritos. They tell you right away that X is burritos and Y is going to be chili. And you're going to have to put numbers in front. Like, you're going to have to put like 20 here and 35 there to make your equations work in the problem below this. The first one was a really easy one. So it was just X plus Y is less than 20. But on the harder problems, there'll be a number in front of the X and a number in front of the Y. But that's basically it. Now, of course, you have an answer key that you can refer to. I strongly recommend it, because then you know if you're doing it right. And I wouldn't wait until you do the whole worksheet and then check it. You might be doing it wrong from problem 1. So I encourage you to be constant about flipping back and forth, taking a look at that answer key, make sure you're doing it right. But if you just copy something over from the answer sheet, you should mark it wrong, but fixed. So that won't hurt your grade. As long as you fix it, you're going to still get 5 out of 5. All right. So that's all I got for you for the new unit. This is called linear programming. Linear, straight lines. Programming means that there's like a system and you're trying to find the answers to a real world problem almost all the time.